Hello my lovely students, you're welcome to a new lesson. Today I shall be teaching you quadratic equations. From definition, a quadratic equation is an equation in which 2 is the highest power of the unknowns. Also, a quadratic equation is an equation of degree 2. That is, the highest exponent of the equation is 2. The general form of a quadratic equation is ax squared plus bx plus c is equal to 0. Let's learn more about quadratic equations. Looking at formation of quadratic equations from given roots, sum and product of roots. The solutions of a quadratic equation are called the roots of the equation. Now, if alpha and beta are the roots or solutions or answers of a quadratic equation, then the general form of a quadratic equation are as follows. The first general form is ax squared plus bx plus c is equal to 0. The second general form of a quadratic equation is x squared minus the sum of the roots, which is alpha plus beta x, plus the product of the roots, which is alpha beta, is equal to 0. In word form, we have it as x squared minus the sum of the roots multiplying x plus the product of the roots is equal to 0. Number 2, the sum of the roots of a quadratic equation is as follows. If alpha and beta are the roots, then the sum of the roots, meaning alpha plus beta, the formula is minus b over a. Number 3, the product of the roots of a quadratic equation, the formula is as follows. If alpha and beta are the roots, then the product of the roots becomes alpha times beta, which is alpha beta. The formula is c over a. Don't forget, a is the coefficient of x squared in the general form of the quadratic equation, b is the coefficient of x, c is the constant term, alpha is the first root, while beta is the second root. Please take note of these formulas. Moving on, let's take some examples on the formation of quadratic equations from given roots, sum and product of roots. Example 1. Find the quadratic equation whose roots are 2 and minus 3 over 4. Let's see the solution to question 1. Here we have two methods that we can apply. In method 1, the roots of the quadratic equation being x is equal to 2 and x is equal to minus 3 over 4. Now let's try to write these two separate equations being equal to 0. We're going to have x minus 2 is equal to 0 for the first equation, and 4x plus 3 is equal to 0 for the second equation. Multiplying these two separate equations and being equal to 0, we are going to get the quadratic equation we are looking for. Now, can you expand x minus 2 in bracket multiplying 4x plus 3 in bracket is equal to 0? Let's see if you can. Expanding and collecting like terms, of course simplifying the equation. The quadratic equation required here is 4x squared minus 5x minus 6 is equal to 0. 4x squared minus 5x minus 6 is equal to 0. I hope method 1 is clear to you. Let's see the second method in solving question 1. In the second method, we are going to use the general form of a quadratic equation, which is x squared minus the sum of the roots, which is alpha plus beta x, plus the product of the root, which is alpha times beta, is equal to 0. Alpha represents the first root, which is alpha is equal to 2, and beta represents the second root, which is beta is equal to minus 3 over 4. What we must do here is to substitute the value for alpha and beta into the general form of the quadratic equation to get the quadratic equation that we require. Let's do this. Substituting the value of alpha and beta into the general form of the quadratic equation, we are going to have the equation as x squared minus 5 over 4x minus 3 over 2 is equal to 0. But this is a fractional equation. Do you know what we must do to change this fractional equation to equation with whole numbers? Let's see if you know what to do. What we must do is to multiply through by the LCM, which is the lowest common multiple of the denominators. The denominators in the fractional equation, they are 4 and 2. The LCM of 4 and 2 is 4. So multiplying through with 4, we are going to have the equation in whole number form. That brings us to the answer once more, which is 4x squared minus 5x minus 6 is equal to 0. This is the quadratic equation whose roots are 2 and minus 3 over 4. So whichever method that you use, either method 1 or method 2, you should get the same correct answer for example 1. I hope the solutions to example 1, they are clear to you. Moving on, let's see our next example. Example 2. Find the quadratic equation whose sum and product of roots are respectively minus 5 and 6 for question A, and 7 over 3 and 0 for question B. Let's see the solution to question 2A. Here we need once more the general form of a quadratic equation, which is x squared minus the sum of the roots, which is alpha plus beta x, plus the product of the roots, which is alpha beta, is equal to 0. Now in question 2A, the sum of the roots, which is alpha plus beta, is the first number given, which is minus 5. While the product of the roots, which is alpha beta, is the second number given, which is 6. What must we do here? We are going to substitute the values for the sum of the roots and the product of the root into the general form of the quadratic equation. In doing this, our answer in question 2A is x squared plus 5x plus 6 is equal to 0. Don't forget to clear your signs and substitute properly. Looking at the solution to question 2B. In the same vein, we need the general form of the quadratic equation, which is x squared minus the sum of the roots, which is alpha plus beta x, plus the product of the roots, which is alpha times beta, is equal to 0. In question 2b, the sum of the roots, alpha plus beta, is 7 over 3, while the product of the roots, alpha beta, is 0. So substituting the values into the general form of the quadratic equation, this is what you are going to get. You are going to have x squared minus 7 over 3x is equal to 0. This is a fractional equation. To change it to a whole number equation, we are going to multiply through by the denominator, which is 3. That gives us our answer in question 2b as 3x squared minus 7x is equal to 0. Moving on, let's take our third example, example 3. Find the sums and products of the roots of the following quadratic equations. Question A, the quadratic equation is 2x squared minus 10x plus 7 is equal to 0. Question B, the equation is 4n squared is equal to 3n plus 1. Question C, the equation is y squared minus 8 is equal to 0. Now, can you still remember the formula for the sum and the product of the roots of a quadratic equation? Let's see if you can still remember. For the solution to question 3a, the sum of the roots of a quadratic equation, the formula is minus b over a. Minus b over a. In question 3a, a is the coefficient of x squared, which is 2. B is the coefficient of x, which is minus 10. C is the constant term, which is 7. So substituting into the formula for the sum of the roots, which is minus b over a, that will give you the sum of the roots being equal to 5. To know the product of the roots in question 3a, the formula is c over a. Product of the roots, the formula is c over a. Once again, substituting your values into the formula and calculating, the product of the roots in question 3a is 3.5. I hope this idea is clear to you. Moving on, let's see the solution to question 3b. The equation is 4n squared is equal to 3n plus 1. The first thing we have to do here is to rearrange the equation properly so that it looks like the general form of a quadratic equation. That becomes 4n squared minus 3n minus 1 is equal to 0. That makes a to be 4, b to be minus 3, and c to be minus 1. The sum of the roots of a quadratic equation remains minus b over a. Substituting your values into this formula, the answer to question B Roman figure 1, which is the sum of the roots of the quadratic equation, is 3 over 4. To know the product of the roots in question 3b, the formula remains c over a. That makes the answer to be minus 1 over 4 from substitution. Let's see the solution to question 3c. Now, from the pattern used in solving question 3a and question 3b, can you get the answers to question 3c, talking about the sum and the product of the roots? Let's see if you can do that. From question 3c, the equation is y squared minus 8 is equal to 0. In this quadratic equation, a is equal to 1. b is equal to 0 because the term for y does not exist. That means that b is equal to 0. c is the constant term, which is minus 8. Now, using the formula for the sum of the roots once more, which is minus b over a, the sum of the roots in question 3c is 0. To solve for the product of the roots in question 3c, the formula remains c over a. That gives the product of the roots to be minus 8 from substitution into the formula. I hope you got that right. Lastly, let's solve some word problems leading to quadratic equations. Example 4. Question A. Find the number which when added to each square makes 90. Question 4b. A woman is 3 times as old as her son. 8 years ago, the product of their ages was 112. Find their present ages. Let's see the solution to question 4a. Here we are looking for a number. Let the number be n. The word problem says when the number is added to each square, it makes 90. That means the number squared, which is n squared, plus the number itself, plus n, should be equal to 90. This is trying to form the equation from the word problem. Arranging that equation properly, we are going to have n squared plus n minus 90 is equal to 0. This forms the quadratic equation. Next, we are going to solve this quadratic equation to get the required numbers. Factorizing the quadratic equation, that means we are going to look for two numbers. When you multiply the two numbers, you get the constant term, which is minus 90. And when you add the two numbers, you are going to get the middle term, which is plus 1. The two numbers are minus 9 and plus 10. So factorizing with this idea, we are going to have n minus 9 in brackets multiplying n plus 10 in brackets is equal to 0. So solving these two brackets separately being equal to 0, we're going to have n minus 9 is equal to 0 or n plus 10 is equal to 0. That makes n is equal to 9 or n is equal to minus 10. The number in question 4a is 9 or minus 10. These are the numbers that when added to each square makes 90. I hope the solution is clear to you. Let's see the solution to question 4b. A woman is 3 times as old as her son. 8 years ago, the product of their ages was 112. Find their present ages. Let the son's age be x years. That makes the woman's age to be 3x years because the woman is 3 times as old as her son. Now let's consider their ages 8 years ago. Of course, both the son and the woman would be 8 years younger 8 years ago. So 8 years ago, the son's age was x minus 8 years. While, of course, 8 years ago, the woman's age was 3x minus 8 years. The question says the product of their ages 8 years ago was 112. That makes x minus 8 in brackets multiplying 3x minus 8 in bracket is equal to 112. Let's expand this and simplify to see what becomes of this equation. Expanding and simplifying, we are going to get a quadratic equation, which is 3x squared minus 32x minus 48 is equal to 0. 3x squared minus 32x minus 48 is equal to 0. This is a quadratic equation. That means the question in 4b has led to a quadratic equation. Solving this equation to find the value of x, let's factorize. Factorizing the equation, we are going to have x minus 12 in brackets multiplying 3x plus 4 in the second bracket is equal to 0. Finally, solving for x from the two separate brackets, we are going to have x is equal to 12 or x is equal to minus 1 whole number 1 over 3. Don't forget, x represents the sun's age. Now, do you think the sun's age can be negative? Let's see. Of course, ages must be positive and cannot be negative. That means that the sun's age cannot be minus 1 whole number 1 over 3 years. The sun's age can only be 12 years. That makes x is equal to 12. Finally, the sun's age, which is x, is equal to 12 years, while the woman's age, which is 3x, is equal to 3 times 12 years, which is 36 years. I hope the solution to question 4b is clear to you.
Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic quadratic equations, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.